The isotope used in a radioactive tracer must be chosen carefully in order to complete a diagnosis without harming the patient. Remember that we use radioactive tracers to investigate organs internally, but we must consider the dose carefully as it can increase the risk of cancer by killing cells, so the dose should be minimised. Doctors have to consider the risk of any irradiation before starting the treatment. The radiation must, however, be strong enough to detect, as we need to map the organ. So if the radiation can't leave the body and is too weak to detect, then this isn't possible. So what about the half-life of our tracer? Well, the half-life must be long enough to complete the diagnosis. Bismuth-83 is an example of an isotope with a very short half-life of just 45 minutes. This half-life isn't suitable, as the bismuth decays before reaching the organ. So the radiation is too weak when it does reach the organ, so it can't be detected. However, it should not be too long, otherwise the patient will be contaminated for a long time. Strontium-90 is an example of an isotope with a long half-life of 28 years. This half-life also isn't suitable, as the strontium will be decaying inside the patient's body for the rest of their lives, and it will cause long-term damage. You don't need to memorise the properties of these isotopes, but let's have a look at what type of radiation we should be using. Beta or gamma emitters should be used to ensure the radiation can escape the body. So remember that alpha, beta and gamma are different types of radiation, each with different ionising and penetration abilities. Beta or gamma could both escape the body as they can pass through tissue. However, alpha won't leave the body as it's stopped by tissue and skin. This also minimises the ionisation that occurs inside the patient's body. Alpha radiation is very dangerous inside the body as it's highly ionising in concentrated areas, so it can ionise an organ and do irreversible damage. However, beta and gamma radiation are less dangerous as they are less ionising, and the radiation is spread out. For your exams, you are expected to be able to explain why the given properties of an isotope make it suitable or unsuitable as a tracer. So which isotope is commonly used for tracers? The most commonly used tracer is Technetium-99. Technetium-99 has a half-life of 6 hours, which is an ideal half-life for a tracer as it can reach the desired organ but doesn't contaminate the body for too long. And technetium emits gamma radiation, which can easily leave the body, so it doesn't cause much damage. You don't need to be able to recall this isotope or its properties, but expect it to crop up in most exam questions involving tracers.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!